oxidation, and acid. So, reviewing again, remembering weathering is this process of taking larger rocks, pieces of cliffsides, pieces of mountains, and breaking them into smaller pieces. We call these pieces sediment, and that really just means it's broken up into rock, it's been weathered. And we've had examples from anywhere from a boulder all the way down to the smallest piece of clay or sand. So in our last video, we spent a lot of time looking at physical weathering. Remembering that physical weathering is where a rock is still made of the same material, it's just smaller. And we saw that there could be various ways that physical weathering could occur, but a lot of it is made through water, whether it be frozen when ice and glaciers and freeze thaw, it could be liquid with abrasion, and all of those things are causing physical erosion. In fact, the vast majority of the weathering on our planet is physical weathering. Today we're going to look at the other side of this chart, and we're going to look at chemical weathering. Chemical weathering is where the rock is still going to stay the same, but the stuff inside of it is going to change. So let's look at chemical weathering. The official definition that I want you to use for your notes is that chemical weathering is the breakdown of rocks and minerals into new substances. That's important. It's a new material, a new substance that's coming off the rock. The rock is still smaller, but it's made of something completely new. Very important. And to understand it, we have to do a little bit of chemistry. So let's kind of review a little bit. Maybe it's some new terms for some of you. But let's look at the difference between atoms, molecules, and rocks, or in this case, the rock. So atoms, we can define them as the basic building block of the universe. That's what makes up matter. It makes up you and me. It's in everything around us, the air we breathe. Now, I understand if you really want to get picky, you could argue that, yes, even atoms are made of materials, things called protons, neutrons, and electrons, and even those are made up of quarks, and quarks could be made up of, well, you could keep going smaller and smaller. But for really any practical purpose, let's go ahead and argue that atoms are the basic building block of our universe. Now, there's over 118 of them. That number has an asterisk by it because they change. We find new elements all the time. More particularly, we're making new elements all the time. When you get above element 113, 112, pretty much all man-made, and they don't last very long. They just kind of disappear. And finally, when you take two atoms, you bond them together, and you can call them a molecule. We can see our next level, after we come from atom, is a molecule. And a molecule is just as a combination of at least two different atoms. In particular, if we were looking at the most common mineral on our planet, quartz, you would see that it's just a combination of silicon and oxygen. You put them together, you get a molecule. You put a bunch of molecules together, you get the mineral quartz. So in a molecule, the atoms are linked. They're binded. They're bound. Yeah, there we go. Bound together. They could be sharing electrons. That's called a covalent bond. They could be something called an ionic bond, where they're just kind of being close to each other and sharing charges. Or there could be other things that are called non-covalent relationships. And we could get a whole bunch, and you'll spend a lot more time in chemistry learning about all those different types of bonds. But in particular, they're held together. And when you take all of those atoms and the molecules, and you take all of those molecules and you put them together, you could get a rock. In this case, the rock. So let's look at how we can change those. How we can change those chemicals to create chemical weathering. So in physical weathering, we saw water played a huge role. And if you remember, we had two charts where water was on both sides, because water plays a huge role also in chemical weathering. It does a process called dissolving. Now, you've heard this term, but it actually means something really specific when we come to chemical weathering. Dissolving is breaking apart atoms that are held together with charges, held like positive negatives, kind of like a magnet. And a water can pull them apart. So, and a great example of this is where water would dissolve salt. Salt's a mineral. Salt is made in the earth. In fact, instead of calling it salt, we might call it halite or an evaporite. These are rocks that are mostly salt. So there's salt water in the ocean, and that water starts to evaporate, or you have like the Great Salt Lake starts to evaporate. It leaves behind the salt, and you get a rock or mineral. So, dissolving would chemically weather that. The salt would disappear, it gets in solution, into the water, it dissipates, and you would weather a rock. It's pretty simple. So the second one we have is something called oxidation. Now remember, I've said scientists just like to use big fancy words to describe things you're already familiar with. That's what you guys would call, what most of us call, is rust. Oxidation is the process of rusting a rock. Some rocks have a lot of things like iron. Iron is really susceptible to rust. And if you have anything in your house like a chain link for your bike, or maybe even your bike, you see it gets rusty. It gets this orange stuff that comes off of it. And what's happening is oxygen gets in there, and oxygen likes to bond to things that have a lot of electrons, a piece of an atom. And it actually changes into the molecule into something called an oxide. And oxides don't hold together very well with other other molecules, and the molecules actually just fall off. You've probably seen this when you look at something rusted and you like rub your hand over it, or pieces of it come off. Well, it's been chemically weathered. That rock is disappearing because oxygen is oxidizing or rusting the rock. This happens. In fact, on the beach, a lot of times you can find rocks that have been oxidized and they almost fall apart because they're breaking down. So we've had dissolving, we've had oxidation. All right, so before we get into understanding how acid is going to chemically weather different rocks, let's go ahead and look what is an acid. Right? I think when we think of acid, we like to think of things just melting away and people, oh, acid fell on me. It's not always like that. So an acid is a molecule that has basically a free hydrogen. It has a piece of it that can bond to other molecules and take away pieces. In particular, hydrogen acids love to bond to oxygen because oxygen has a lot of wants an electron, wants to take in a hydrogen, and when it does that, it forms water. Right? So acids bond to oxygens and create water. In fact, if you think about it, if something has a free hydrogen, water is H2O. It means it has it has two hydrogens, so they bond together. So we like to also label acids. Right? If an acid has a pH, right, so any liquid, we can go ahead and find the amount of hydrogen in it. It's called parts per million of hydrogen, or pH. If there's a number of less than 7, then that is an acid. So if you hear of a number like pH 3, pH 4, that is something that is an acid. Whereas if it was above 7, it would be something called a base. So we don't need to worry about bases today. But pure water is 7. So if you take an acid, you take an equal base, and you put them together, you should get pure water at 7. Don't try that, though. That could be really dangerous. So let's look at some common acids. What are acids we could find? Well, you can find carbonic acid. Carbonic acid is actually what you get when carbon dioxide in the atmosphere mixes with water, and you get carbonic acid. Sulfuric acid and nitric acid are caused when we burn fossil fuels, or we burn oil products, or oil, or coal in the atmosphere. We get these things called sulfuric and nitric acid. Your stomach has acid in it. That's hydrochloric acid, very strong. There's also things called like phosphoric acid. So, and there's even more. I could have listed tons and tons more. In fact, you're made up of acid. DNA, right, is an acid. That's what the A in DNA stands for. It's an acid. So let's look at what acid can do if we start to weather it, when we use it for weathering. So we have acid and we put it in groundwater. Sometimes water has less than just a little bit of acidity in it. And over time, you can get a really beautiful place, right? You might see a cave where you have stalagmites and stalactites. Or maybe I flipped that. I'm pretty sure I'm right. Creating these nice, beautiful spires you see. What's happening is you have a rock called limestone or even marble, and those rocks are being broken down by the acid. Actually, those are limestone and marble, two rocks that really are easily weathered. And so they break down and they build up and create these spires. But what you're seeing is acid chemically weathering rock in groundwater. Right? So it's a chemical weathering that's creating that cool cave, and more bats will fly out and we get these little creepy crawlies. So we could have acid in groundwater. We also have acid in living things. I know if you look at rocks around here, just out when you go hiking, or maybe they're in your yard, or maybe you're looking at like pieces of our school, you might find these brownish or green or orange or kind of yellowish things that are on the rock. And they're kind of these flat, they're really strange. They almost look like a plant. They're not exactly a plant. What they actually are is something called a lichen. And lichen are living things. And they are actually eating the rock. Well, that seems strange. But what happens is a lichen is actually getting minerals and material from the rock by excreting acid and eating into the rock. Sometimes geologists like to call this biological weathering. Now, really, it's just chemical weathering, but life is doing it. These lichens are carving out rocks. Next time you see a rock with these weird, orangish, green, white spots, you know that that rock is being weathered. It's much more common in really wet areas. That's why if you went to Central Oregon, you would see less lichen than you would see, let's say, over here in the Willamette Valley. So we have, it could be in groundwater dissolving. Acids could be in living things. The third type of acid is something called acid rain, and it's a little bit more dangerous and a little bit more common lately. Acid rain is considered any type of weather form. It could be snow, it could be rain, sleet, hail, we'll go through it all, that contains acid. So, what happens is as we have factories and we have power plants that are burning fossil fuels, things that are coal and oil and gasoline and natural gas, it's releasing sulfates, SO2 and NO3,4, it could be anything. These are actually molecules that are in the smoke or in the pieces that are coming off of the factory, and they're going up in the air and they're getting into the water and creating an acid. It could be nitric acid, it could be sulfuric acid, and it's getting into the air, it's getting in the water. Now, is it enough acid that if you happen to be outside, let's say in the rain, you'd be burning and turning into the witch from Wizard of Oz? No, it's not that strong. In fact, you wouldn't even know it. In fact, to be honest with you, most water is just a tiny bit acidic, but this is more acidic. So, we have an acid inside the rain. This is really common in different places of the United States. Now, you can look at Oregon and we're in green. That's really great. We don't have a whole lot of like coal plants or things like that, or factories that are putting out fossil fuels and pollution. But on the other end, if you look over there in Ohio, in Pennsylvania, parts of New York, New Jersey, right, we have what's called the Rust Belt. Lots and lots of carbon and coal and being produced, and is creating this acid rain. It's also kind of interesting to notice that the wind goes from the west to the east. So those pieces of smoke and the pollution from them are being carried east. And so as you go further east, you're getting more and more acid rain. Well, acid rain has a really big chemical weathering. In fact, it's most easily to be seen on statues. Right? So if you look at these first set of statues, at one point it was carved to be this beautiful woman, but as acid rain has fallen over the many years, pieces of that have been weathered away, have been taken now and smooth. And now, if you look at that picture of the woman, you couldn't even tell it was a woman. It was just some weird blob. Same for gravestones. Gravestones are very often made of limestone and marble. It's really easy to carve that. Well, it's also very easy to weather it. There has been a big push for many of like the Civil War or even like patriots or our forefathers. A lot of the gravestones in the colonies are starting to weather away from all this acid rain, and it's causing quite a big deal. Now, it's really easy to see it there, but it's also happening to rocks. The difference is a rock starts off in a weird shape, and as it's weathering, it's still a weird shape. You couldn't tell, but it's being chemically weathered away. So, let's kind of backtrack. Acid rain is caused by pollution, and it's a form of chemical weathering. And really, an acid is just a molecule that has a free hydrogen that likes to bond to other stuff. You could have oxidation, and oxidation for chemical weathering is simply rusting a rock. It's taking oxygen and adding it to a molecule and making it not want to bind to other molecules, and it breaks apart. It's That's chemical weathering. Or you could have dissolving, which is where water